Working in this big blast chiller today on this coil that has a really bad leak, and it's leaking right, no, that's not in focus, but it's leaking right there. You can kind of see where that U-bend is almost like cut down into the steel. The plan is going to be to clean it up really good, and taping a Scotch-Brite pad onto an extension is one of my favorite ways, although it's still very difficult to clean that way. And then we're going to flux it really well and use safety silv on it. And the idea is just to bond the metal to the copper, and in the process fix the leak. So we'll see how it works. If it doesn't work, and I've showed this before, we'll just have to eliminate that circuit. I'm not even sure this coil's made anymore. This unit's like from the 80s. I've got it cleaned up now as good as I can get it. So I used the bit and also a really long, narrow thing of sand cloth, you know, doing the whole back and forth saw action, and then of course rolling it up and using some needle nose to get in there. So now it needs flux, because you can't, you have to use safety silv on steel. You can't use anything with phosphorus because it'll create iron phosphites. Fates. Anyways, you have to use the flux, because without the phosphorus, you're not going to have any fluxing action whatsoever. This is safety silv, and it's like 45% silver and the rest is copper. It flows really nicely. In fact, it's better for this because it'll flow in. Silphos is better for filling gaps and things like that. And this is the brazing flux I'm going to be using. Harris also makes a black brazing flux, and it has a higher activation temperature, and it's really good on stainless steels and things that you have to get a little hotter than normal to braze. Heard some crackling down in here, and the pan heater was all shorting out and everything. This site is just a real can of worms. All right, I want to find out what voltage this thing is so we can try to get something to take its place, and I'm just going to try to go generic on that. So I want to find out the voltage. Now, there's a couple ways of doing this, but one of the easiest ways, at least in this space, is just going to be to tap into it. So I'm going to use these wire piercing probes, and I've got this in no contact mode, so see we got voltage there, and this is how these work. Now I should say this is my favorite set by far, even though technically the rating is not high voltage. They are fine in my opinion, but I wouldn't recommend that you use them. All right, so you can see there's a needle that comes up there and pierces through. So I'm gonna do these, and then I'll show the voltage. All right, I'm tapped in right there, and we got a 120 volt heater, so that's what we're gonna get at the supply house. I made a pretty bad mistake yesterday and turned something into a big old pile of dog shit here. So you see that like burned out? It's not in focus. Hang on, give me a second. There. Yeah. I don't know why, but I was thinking this is steel. It's not steel, it's aluminum. So, you know, I noticed it starting to melt and then realized it was aluminum, and I tried to melt it out so I could braze the copper, but by then it was already contaminated. And it would not take the braze because that aluminum was like mixing in with everything. But it ended up working out, I think, for the best, because this area of coil is just so bad that there's nothing we can do about it. You know, like once we got that leak fixed, another one showed up, then another, and we kept having to go up higher. And that's not uncommon when you have a coil that's in this poor of condition. And so what we ended up doing is removing a couple circuits, and I hate doing that, but it's going to decrease the efficiency, but it's going to get them up and going. And that's one of the big goals with refrigeration. And you know, they can replace this system, and they need to, but they can do that. The goal today is just to get them going. I wanted to show that, you know, as a tech, you have to embrace mistakes. Well, as a human being, you have to, because that's how you learn. And when I say embrace, I don't mean enjoy. I hate making mistakes, but it's part of life, and you gotta embrace them and admit to them and all that good stuff. It's part of the life journey. Okay, we fixed another one there, but didn't take that circuit out. It held pressure overnight, which is a real great sign. So we're gonna move on to calculating the charge, and I'm gonna show some real cool things about that. Here's our big old receiver, and we need a length measurement and a diameter. I'm gonna find out how much refrigerant is in this thing, and I'll show how to do that, and then we're gonna calculate how much we need. Now, the calculations for a vertical cylinder are pretty easy, but when you're trying to calculate volume for a horizontal cylinder, the math gets a lot more complicated, but I'll go over that. So anyways, what I'm gonna do is I'm gonna get this end cap nice and hot, and then I'm gonna look at it with thermal. I'm gonna see where the liquid level is. You can also feel, and you'll feel it'll be cool, 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 and then it'll start getting hot as you start to heat the area of the receiver that's nothing but vapor. To heat this, you just want to evenly run it across the surface, up and down, up and down. And with the thicker wall, you just want to make sure that you got enough heat where it's soaking through into the refrigerant. Wow, I don't know how we got this lucky, but we're not missing a lot of refrigerant. So there's the vapor line right there at the top. Everything else is liquid. That is phenomenal. All right, go ahead, broski. This is how you would do it without thermal. So it's cool, cool. And you're being careful so you don't burn yourself. Come where you feel the difference. Right in there, right in there. And that's where we marked with the thermal. So there's definitely, you can feel, it's a surprisingly sharp temperature gradient between the two halves right there. Bottom of the line and the top. Now, your goal on receivers is basically, when the system is pumped down, to be at like an 85-90% fill, somewhere in there. You do want some head space, but you want a lot of liquid in there, especially if you got a headmaster. You know, you don't want to just clear a sight glass. You got to clear the sight glass, and then you got to make sure your receiver is full. It doesn't look like we need to add refrigerant to this. I believe we caught it fast enough. As I already mentioned, when the receiver is vertical, it's very easy to calculate the volume because it's just the volume of a cylinder. But when it's horizontal, it gets very tricky because you're not dealing with a cylinder shape anymore. But in the case of the receiver we were working on, let's say the liquid level was up 5 inches. Then I built a calculator here to calculate this volume right here, this 8 inches of volume. And then of course, use the refrigerant density, this is 404A, to calculate the fill. So if we were 8 inches low and we wanted an 85% fill, we would use this amount in pounds. I prefer the metric system, but the way our tape measures are and scales, I do everything in metric over here, but the math for this gets complex. It's one of the reasons I wrote a formula for it, so I just do it automatically. And I'm gonna see what I can do about making some resources available, and I'll talk more about that. There are gonna be some good changes coming up on the channel. Anyways, that may be all I film. I'm not sure. I'm gonna probably move on to something else and let another tech wrap this up. So it's gone about as good as I could hope for. This is a rough system to work on. It's not my first rodeo on that system.